everyone, this is a session on General Aptitude. In this session, we'll deal with the topic time and distance. Here we'll cover the topics average speed, relative speed, time to meet or overtake, and train problems. So this will be a class on the concepts, formulas, and also do some practice problems. So let's get started. First, we'll see the basic formulas of distance, speed, and time. That is distance, speed, and time. Distance is equal to speed into time. Then speed is equal to distance by time, and time is equal to distance by speed. Okay. Now while doing the problem, we'll have to do some conversions, that is from kilometer per hour to meter per second, and meter per hour to meter per second to kilometer per hour. So this conversion is shown here. From kilometer per hour to meter per second, we have to multiply by 5 by 18, and from meter per second to kilometer per hour conversion, we have to multiply by 18 by 5. Okay. Next we will see average speed. First one is average speed for varying distance. That is, a journey consists of different distances covered at different speed. That is, a man has to travel from point A to point B, then from point B to C, and C to D. That is, these distances from A to B is D1, B to C is D2, and C to D is D3. These distances are not same. These are different distances. So, and the total time taken for this journey is t. Then the average speed would be the total distance by total time. Then the total distance is d1 plus d2 plus d3 divided by the total time is t. Okay, this is average speed for varying distance. Next is the average speed for equal distance at different speed. That is, if a man is going from A to B at a speed of s1, and he is returning from B to A at a speed of s2, that is, the speeds are different. Okay, in such cases the average speed is found using the formula 2s1 s2 divided by s1 plus s2. These are the formulas for average speed. Next we'll see the topic relative speed. Okay, relative speed, we'll find the relative speed when moving in same direction and also in opposite direction. Okay, for example, two trains are moving in same direction, one at 80 km per hour and second at 60 km per hour. Okay, then the relative speed will be the difference of their speeds. That is, relative speed is equal to 80 minus 60, that is 20 km. So when the train is moving in the same direction, then the relative speed will be the difference of their speeds. And now if the train is moving in opposite direction, that is train A in this direction and train B in the opposite direction. Speed of first train is 80 km per hour and speed of second train is 60 km per hour, and they are moving towards each other. Then the relative speed will be the sum of their speeds. That is, relative speed is equal to 80 plus 60, which is equal to 140 km per hour. This is about relative speed. Next is the time to meet or overtake. That is, if there are two cars, that is 300 km apart. That is, car A and car B, they are 300 km apart. And this car A and car B are moving towards each other. Then the time taken for both the cars to meet. What would be the time taken? We know that time is equal to distance by speed. So here the distance is 300 km and the speed would be the relative speed. Okay, the relative speed. What is the relative speed? When they are both are traveling in opposite direction, the relative speed would be the sum of their speeds. So if the speed of this car is 50 km per hour and this car is 70 km per hour, then the relative speed would be 70 plus 50, sum of their speeds, that is 120 km per hour. Now the time taken would be distance, that is distance by relative speed. Distance is 300 kilometers divided by the relative speed, which is 120 km per hour. Now this is 2.5 hours. This is the time taken to meet. And next case is overtaking time. That is, if there are two cars 100 meters apart. Okay, this is car A and it is traveling at a speed of 20 meter per second. And there is a second car B. It is traveling at a distance of at a slower speed, that is 15 meter per second. Both are traveling in same direction. Then what will happen? This car A will overtake car B. And what is the overtaking time? Here also the time is distance divided by the relative speed. Here the distance is 100 meter and the relative speed would be, since they are both are moving in same direction, the relative speed would be the difference of these two speeds, that is 20 minus 15. So the time would be 20 seconds. This is about the meeting time and overtaking time. That is, meeting time is distance divided by relative speed, and overtaking time is also the time distance divided by relative speed. Here, since they are moving towards each other, the relative speed would be the sum of these two speeds. And second case, since they are moving in same direction, the relative speed would be the difference of their speeds. Next is train problems. We'll see some train problems in exam. Uh, there are two cases. If the train is passing a stationary object and train is passing a platform. When a train is passing a stationary object like a man or a pole, okay, in exam such questions will be given. A train is passing a man or a pole, a stationary man or a pole. And in this case, the distance we take it as length equal to length of the train. Okay, distance is taken as length of the train. So what would be the time taken by the train? Time would be distance by speed. We know that time is distance by speed. So here distance is length of the train. Let we take it as LT. That is length of the train divided by speed. So the time taken would be length of the train divided by speed, if the train is passing a stationary object. In the second case, the train is passing a platform, or we can say a train is passing through a tunnel. In this case, the distance will be equal to length of the train plus the length of the platform. So here what would be the time taken? Time taken is distance by speed, where distance is equal to length of train plus length of platform divided by speed. So these are the two cases. Next we'll get into some of the practice problems. First question. A train of length 110 meter is running at a speed of 60 km per hour. In what time it will pass a man who is running at 6 km per hour in the direction opposite to that in which the train is going? Given that length of the train, that is LT, is 110 meter and its speed S, speed of the train is 60 km per hour, and it is saying that it passes a man who is running at 6 km per hour. This man is running at 6 km per hour, that is the speed of the man is 6 km per hour. So since both are moving, okay, in which direction? In opposite direction. Then what would be their relative speed? When they are moving in opposite direction, these two speed are to be added. That is ST plus SM, which is equal to 60 plus 6, 66 km per hour is the relative speed. Now we have to find the time it will take for the train to pass the man. So we know that time is equal to distance by relative speed. So here distance is equal to length of the train. We have already discussed that when train is passing a stationary thing, that is man or a pole, the distance will be the length of the train divided by the relative speed. Now length of train is 110 and the relative speed, this is given in meter, 110 meters. So this relative speed to be converted to meter, that is 66 km per hour. Converting it into meter, we get 66 into 5 by 18. This is equal to 55 divided by 3 meter per second. So relative speed is 55 by 3. Now this is equal to 110 into 3 by 55. That is 10, 5, 30 by 5, which is 6 seconds. This is the time taken for the train to pass a man who is running in opposite direction. Option C. Next question. A train that is 280 meter long traveling at a uniform speed crosses a platform in 60 seconds and passes a man standing on the platform in 20 seconds. What is the length of the platform in meters? It is given that length of the train is 280 meters. It is traveling in a uniform speed and it crosses a platform in 60 seconds. That is, time taken to cross the platform is 60 seconds. And it passes a man standing on the platform in 20 seconds. That is, time taken to pass the man. Okay, time taken to pass the man is 20 seconds. So we have to find the length of the platform. Okay, first we'll see this case, that is a train passing the platform. Okay. Then we know that speed is equal to distance by time. Okay. When the train is passing a platform, we have already said that the distance is equal to length of the train plus length of the platform divided by the time to cross the platform, that is TP. Now this is equal to 280 plus length of the platform divided by TP is 60. This is the first equation. Now we'll take the second case, that is the train is passing a man. Okay. When the train is passing the man, so what would be the speed? Speed is equal to again distance by time, and here the distance is only the length of the train. When train is passing the man, the distance would be the length of the train, and the time is to pass the man is Tm. So here LT is 280 divided by Tm is 20. Now this is the second equation, and it is also said that the train is traveling at uniform speed. That means these two speeds are equal. So we can equate equation 1 and 2, that is 280 plus length of the platform divided by 60 equal to 280 divided by 20. Now we can simplify this and we get LP equal to length of the platform equal to 280 into 3 minus 280, which is equal to 560 meters. So this is the correct answer. Next question. A metro train runs at a speed of 45 km per hour. It covers a total distance of 72 km on its route from origin to destination in 2 hours. That includes stop at intermediate stations. If it stops for 2 minutes at each station, how many intermediate stations are there in the route? It is said that the metro train has a speed of the train is 45 km per hour. And the total distance it covers, that is the distance is 72 km. So what would be the time taken by the train to travel this much distance with this speed? We know that time is equal to distance by speed, that is equal to 72 by 45. This is equal to 8 by 5. Okay, that is 3 by 5 hours. This is the time taken, 1 hour and 3 by 5 minutes, 3 by 5 hours. This is the time taken for the train to travel this much distance with a speed of 45 km per hour. But it is said that from origin to destination it takes 2 hours. That includes stop at intermediate stations. That is, the train actually takes, the time taken by the train is 2 hours. 2 hours. Actually the train has to take 3 by 5 hours or 8 by 5 hours. Okay, 1 hour and 3 by 5 minutes, but it takes 2 hours because it is stopping at intermediate stations. There are many intermediate stations in between, so it stops at these stations. So it takes extra time. That is, how much time extra it take? Extra time taken. The extra time taken is 2 minus this 8 by 5. That is equal to 2 by 5 hours. This much time it is taking extra, and this extra time is spent at the intermediate station. The time taken at the intermediate station is 2 by 5 hours. Okay, now It is said that in each station it stops for 2 minutes. Now we'll convert this 2 by 5 hour into minute. Okay, that is equal to 2 by 5 into 60. Which is equal to 24 minutes. Okay. Now the time taken by the train in the intermediate stations is 24 minutes. It is also said that it stops for 2 minutes at each station. Each station it stops for 2 minutes. And total the time taken in the intermediate station is 24 minutes. Then how many intermediate stations are there? Number of intermediate stations station would be 24 by 2, which is 12. Okay, so the answer is 12. Next question. Train travel time between station A and B is 39 hours. Every day, a pair of trains leave from A to B and B to A at 6 a.m. If the service starts on a Monday, on which day earliest will the same train start the journey again from their original station? It is said that there are two stations. From A to B, train is leaving at 6 a.m. in the morning, when Monday morning. Okay. Every day the train will start from 6 a.m. In both the station, the train starts at 6 a.m. Now, this distance between these two stations is 39 hours. It takes 39 hours to travel from A to B and also from B to A. So, the train starts at 6 a.m. on Monday and it goes to station B and it returns from B to A. Okay. Then on which day earliest will the same train start the journey again from the original station? And next, when would the train start from this station A? So first we'll see from 6 a.m. on Monday it started the journey. Now when will it reach B? We'll see that 6 a.m. on Monday it started. Then after 24 hours becomes Tuesday morning 6 a.m. Okay. Now after 12 hours it becomes Tuesday evening 6 p.m. Okay. Now how much hours it has traveled? That is 36 hours. Now there is 3 more hours left to reach the station, that is plus 3 hours. That means 6 plus 3, that is 9 p.m. On Tuesday it will reach station B. Okay, it will reach station B at Tuesday 9 p.m. Now will it start again from B to A at 9 p.m. on Tuesday? No, it will start the service only at 6 a.m. So it will wait till next morning, and on Wednesday morning 6 a.m. it will start the journey. Now when will it reach A? Again it takes 39 hours, that is Wednesday 6 a.m. it started the journey. Then it will reach at Thursday 9 p.m. Okay, it will reach here at Thursday 9 p.m. Now again will it start the journey on Thursday 9 p.m.? No, it will wait till next morning 6 a.m. So next morning, that is Friday morning 6 a.m. it will start the journey again from A to B. This is the day earliest. Which day earliest will the same train start the journey again from the original station? That is from A to B it went, then it returned from B to A, and again it start from A on Friday. So this is the answer. Next question. This is a homework question for you. A man is walking at a speed of 15 km per hour. After every kilometer, he takes rest for 3 minutes. How much time will he take to cover a distance of 4 km? So comment your answer in the comment section. So this is all for today. Thanks for watching.